Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
An OLED display with the Raspberry Pi Pico? Well, let's get into it. Hi, and welcome to Robocraze. My name is Shiv, and in this video, I'm going to teach you how to interface an OLED screen with the Raspberry Pi Pico and program it using MicroPython. This video is a fourth in our series where I am teaching you how to program the brand new Raspberry Pi Pico microcontroller using MicroPython. So if you haven't checked out the other videos in the series, I highly suggest you check them out and then come back over here. I'll leave a link to the playlist in the description down below and in the cards up over here. So let's get started. So let us begin by setting up the hardware. I have the Pico and the OLED screen on the breadboard over here. Next, I'll take 4 jumper wires and connect them to the 4 pins on the OLED screen. These pins are VCC, ground, SCL and SDA. In that order, VCC, ground, SCL and SDA, and I've connected these over here, and next I'll go and connect the VCC and the ground pins on top over here. If you have seen the series till now, I'm sure you remember these pins. Otherwise, you can refer to the pin out diagram that I have on my screen over here. So fifth from the left on the top is 3.3 volts, and the one besides it over here, third from the left, is ground. Now that we have those connected, let us connect our SDA and SCL pins. Now if you see over here, this pin is I2C0 SDA and the next one is I2C0 SCL. Physical pin numbers 11 and 12. So I'll go ahead and connect those, and there. Our connections are now complete. Let us now look at the script and see how this would work. So now we are in our Thonny editor. Using the shell below, let us first check if the OLED screen is being detected on the I2C interface. So from machine, import I2C, since we need to use the I2C functionality. Now if you remember in the circuit, we have connected the I2C 0 interface. So I'll declare an I2C variable as the I2C 0 default interface. It will automatically take the SDA and SCL pins that we have connected over here. Those are the default pins. Next we can call the function I2C.scan and it will return all the detected devices on the bus. As we can see, the address 60 is getting detected. 60 is the same as 0x3c in hexadecimal. So our OLED screen is detected on the address 0x3c. Next you will need the SH1106 library. I will put a link to this in the description down below. We'll upload it to our Robocraze GitHub account and I'll add a link to it in the description down below. You can see over here it takes the default address. If we use I2C, it takes the default address of 0x3c. So this is sorted for us. Once you follow the link and you get the source code for this file, copy it and click on new over here. Paste the entire contents of this file that you got from GitHub onto the IDE and then press the save button. When prompted where to save, I'll just do save as so that I can demonstrate this once. It'll ask where to save. Select the Raspberry Pi Pico, go to the lib folder and save it as sh1106.py. I have a lot of other libraries here, but this might be empty for you. So just select sh1106.py and press OK and it will save it in the lib folder. Once that is done, we can go to writing our main script. I'll first import the I2C class. From machine, import I2C, and next from the library that we just added, sh1106, we will import sh1106 underscore I2C, since our variant over here runs on I2C. Next I'll declare the I2C variable and I'll assign it to the default channel 0, I2C 0, and then we can declare our OLED variable, our OLED object, as sh1106 underscore I2C, and then we need to pass it first the width and the height. So this is a 128 by 64 screen. So I'll pass 128, 64, and then the I2C handle. This we have just created right now, like this. Now what we can go ahead and do is I'll just do OLED dot fill 0. This kind of just clears out the screen if there's anything. And then let's do OLED dot text, and then we write some text. So Robocraze, let's just write Robocraze, and the coordinates where we want to print it. So let me just choose 5, 10. So 5 across and 10 down. So somewhere over here it should print it. 5 across and 10 down, and these are in pixels. Once that is done, we need to call the OLED.show method. Now what this will do is it will finally display, it will update the OLED with whatever we have asked it to display. So basically it will display this text. Let us run it and see what happens. So we get a text, but it's upside down. Now this is easily fixable. I just have to do OLED.rotate and pass it true. So that will rotate the screen for you, and there, it's the right side up now, and we can actually go ahead and print more things. Let's print hello Robocraze. I'll shift this one down by another 10 points. So let's say 5, 20. I run this, and there, we get hello Robocraze on the screen. You can keep going ahead and adding as many lines as you want. I'll add Pico for instance. And once you call the show function, it will update the screen. What will happen if I comment out the show function and run it is that nothing will really show actually. So it will not update the text on the screen. It has cleared the screen, but the text does not appear unless I call this function. So that is just the basics of how to how to print any text on the screen. Let us now look at a slightly more advanced applications. Let's try printing some values on the screen, some variable. So for that, I can go here and declare, say, a counter. I'll declare it as 0, and now I'll remove all of this. We'll print something fancy now. Let me just say hello, and then I'll put braces over here and call the format function and pass it counter. Let's put this in a infinite while loop. So there we have it. We'll display hello, the counter, and then let's increment the counter by 1. And just so that this doesn't happen too fast, I'll slow it down a little by importing time. Import time and time.sleep, and we'll sleep it for 1 second, let's say, or let's make it a bit faster. Let's make it 0.5. And yeah, I am going to run this now, and let's see what happens. So as you can see, it says hello 0, and then it tries to display something, but it all gets jumbled up over here. Now the reason that is happening is because I forgot to clear the screen. So I'm going to cut this from over here, bring it inside my while loop, and there. Now this should clear the screen before we try to print something. So basically this is what is going to happen if you don't clear your screen. It is going to print over and over on top of that, overwriting it until it becomes just a jumble of things that you can't really read. So let me run this now, and hopefully we have a better output. I'll press the run button, and there, much better. Now we can see all the values that are coming. Now we can take this one step further and try connecting one of the sensors and the input devices that I showed you in my last video. Let us take the potentiometer now. So I have now connected my potentiometer to the Pico. I've described these connections in the last video. You can go and check that out. I'll leave a link in the description down below. But I'll give a brief explanation of how I have connected it. So I've connected the two ends of the potentiometer to VCC and ground. So the same VCC and ground that we used for the OLED, the same ones are now going over to the potentiometer. And the middle wire, the middle pin of the potentiometer now goes through here to pin number GPIO 26 basically. So this pin, It is the 10th from the left on the top. Pin number 26 is ADC channel 0. Now what I can do here is I can import ADC from machine, declare my ADC object as ADC channel 0, and instead of displaying hello, let us just display, I'll just remove all of this and just display adc.read_u16, and we can remove the counter, we don't need it anymore. We can remove this as well. We can make this much faster so that we don't have a delay in whatever values we read over here. And yeah, this looks good to me. Let me just run this now and let's see if we get an output. Can't convert int object to string implicitly, so let us help it out by typecasting it to string explicitly, since it can't do it implicitly. Alright, so you can see we have some numbers coming up over here. Let me just rotate this to the right. Hopefully the numbers increase. Yeah, they do. Goes to a maximum and we reduce it back down all the way to a minimum. So there, we're reading values from the potentiometer and displaying them on the OLED screen over here. We can go ahead and attach more input devices as I described in my last video. So let's take the example of a button now. So we'll add a button to this entire system in addition to the potentiometer. And then maybe we can display a count every time we press the button. So that will be a fun little application. I now have a button on my breadboard over here. This pin you see over here, GPIO 26 ADC channel 0, this is where this pin is going, the pin from the potentiometer. Now the button, let us set to pin number 14. So a GPIO 14 that you can see over here, second on the bottom over here, second from the left on the board here. So this is the same pin we used in our last video and I'll just reuse that pin. I will connect one end of the button to that pin. And in the last video I showed you how we configured this as an input pull down. So that is why I'll connect the other end of the button to the VCC pin over here. So we'll just share the VCC pin with the potentiometer over here, and that will be good. Now I can go to the Thonny editor. So this is where we have connected GPIO 14 for the button and GPIO 26 for the ADC channel 0. So let's go back here and over here let's do one thing. I'll remove this explicit typecast and I'll remove this. Okay, maybe keep that. And let me just say ADC colon braces dot format and ADC U16. So just so that we can make out which value is which, I'll just print ADC colon and then replace this with the value that we read from the ADC, and then we can just write our second string over here. So let's call this button and I will just display a counter over here, and I'll declare the counter on top like so as 0. I now need to import pin. We need to declare our button object. I've covered all of these in the last video, so you can go and check that out. I explain it much more slowly over there. So now we declared as pin 14, pin.in and pin.pull underscore down, because we needed to be in pull down configuration. Now let us do this using interrupts. So what I'm going to do is first declare my button callback function, and I explain as I explained in my last video, all these callback functions have to take the pin object, and once we have the callback, inside that let us just increment the value of the counter. So I'll just say global counter so that it knows I'm trying to access the global variable counter, this one, and then this we can say counter plus equal to 1. So we'll just increment the counter, that's it. Now we can attach this interrupt to the button. So let's say button.irq, our callback, which is the button callback, and our trigger. So pin.irq underscore, let's do a rising edge, because well, why not, we'll do a rising edge. And let us run it and see if we get an output. Alright, something weird is going on. That is because I did not change the coordinates over here. It's overwriting all over each other. So I'll just make this 20 and let me run this again. I should bring the button counter down. So as you can see, the ADC values are still coming. I can rotate the potentiometer and make the values change. And now let's try pressing the button and see what happens. Oh, and the values increase. Now you see, every time I press the button once, the values change many times. Sometimes it changes once like it did right now. Sometimes it changes multiple times. So once. See, there it changed twice. So this is a phenomenon called bouncing. So the button is essentially, the button internally has an electrical contact, mechanical contact actually, which when you press the button, it touches, and when you release the button, it breaks the contact. Now what happens is, sometimes when you press or release the button, it can cause the contacts to bounce very rapidly before settling down. And that is what causes multiple values to show up over here. So in order to handle this debounce issue, I'm just going to put a quick and small fix over here that you can try. So I'll declare a variable over here called last button time, and we'll declare it as 0. So this will store the last time that the button was pressed, or we registered a press from the button. And what we can do is, I'll actually import U time now, because we need the number of milliseconds that have elapsed, because we need to do this on a millisecond level. So U time, we'll import it. I'll just go over here and add the variable last button time, since we will be manipulating it. Now we can say if the current millisecond, so U time dot ticks underscore ms. This ticks underscore ms gives us, is similar to the Arduino millis function. It will give us the number of milliseconds that have elapsed since the program started, minus last button time. So if the difference between the current milliseconds and the last time that the button was pressed is greater than, let's say, debounce time. So we can declare some constant over here, debounce time, and if it is greater than that, only then we will consider it as a valid button press, and we'll increment the counter, and we'll just set the value of last button time to whatever the current time is. So ticks underscore ms. We now go ahead and declare this variable over here on top. So we can consider it to be 200 milliseconds. 200 milliseconds for this application is fine. If your application is more time sensitive, you can try reducing this a little bit, but that gives you lesser time to press it and get your hand away from it. So 200 milliseconds is good enough for our application. If the time minus the last time the button was pressed is greater than the debounce time, then we go ahead and register the button press by incrementing the counter and updating the last button time as the current time. Let's run this and see what happens. Hopefully we don't get any bounces anymore. So I press it once, twice, thrice. I'll just keep pressing it at least 25 times, because last time when I went till 25, we saw it bounced quite a few times. But as you can see now, consistently, no bounce. So this is a quick and dirty fix that you can try try with buttons in an interrupt kind of a scenario. You can also use hardware debouncing. There are hardware debouncing circuits that you can try out as well. And I can even change the potentiometer. The potentiometer works and the button works. Now you can go ahead and connect any number of sensors or input devices or even actuators to this, and just print the status or the values on the screen over here, and use your imagination to come up with more applications. That's all for this video, guys. I hope you enjoyed it. I hope you learned something today, and if you did, do leave us a like and comment down below if you have any queries, suggestions or ideas that you may want to share with us. Don't forget to subscribe, because in the next video I'm going to take all that we have learned in these 4 videos so far and combine it to make a game on the Pico using MicroPython. So we'll use the OLED screen, we'll use the Pico and a few other components to make a basic game, and I'll teach you how to do that. So stay tuned. In the meanwhile, keep learning, keep programming, and I'll see you in the next one.